In this video, we'll be solving an equation which contains a logarithm. The first example that we'll be doing is we're asked to solve this exponential equation. 42 raised to the log base 42 of 5 is equal to x. Now, to change an exponential to a logarithm, if we have an exponential, b raised to some exponent x is equal to a, we can change that to a logarithm. By the way, this goes both ways, so you can change from a logarithm to an exponential. You can change this to a logarithm by using the log with a base of b. Since my exponential has a base of b, my logarithm also has a base of b. And we know that a logarithm is an exponent. So this exponent right here is what my logarithm is equal to. And this is my argument of my logarithm. So I'm going to use this rule. This is my exponential. And I'm going to change it to a logarithmic statement. So I want to write log. My base of my exponential is 42. So 42 is the base of my logarithm. Now my exponent on my exponential is the right side of my logarithmic statement. So I need to put the whole exponent over here, log base 42 of 5. And then my argument of my logarithm is x. Now if you look at this for a minute, you can see that we have logs on both sides, and they're the same base. And so I can say that my arguments are equal. So I can then say that x is equal to 5. Let's do another one. Again, we have an exponential. I'm going to change it to a logarithm. So I'm going to write log. The base of my logarithm is the base of the exponential, which is 9. My exponent, which is this whole thing right here, is what my log is equal to. And then x is my argument on my logarithm. Again, match up your pieces. You have logs on both sides. Okay, we're going to have to change our tactic here because we need to have the same base. So can't do this like this yet. But I can get a base of 3 out of this problem by rewriting this. So let's do that. 9 is 3 squared. And then that's raised to the log base 3 of 5. And now let's try this problem. We know that when we have a power to a power, we multiply the exponents. So this is 3 to the 2 times log base 3 of 5. And then I know that this 2 can be brought up as the exponent on my 5, on my argument. So I'll rewrite that, 3 raised to the log base 3 of 5 squared. Now let's do the same thing that we were going to do up here. Let's change this to a logarithmic equation. Now log. My base of my exponential now is 3. So that's the base of my logarithm. My exponent on my exponential is all of this. So that's what equals the log here. So I have to write all of that. And then the x is my argument on my log. Right, I know that 5 squared is 25. You can either do that now or in a little bit. We know that we have logs on both sides, and this time the bases are the same, so we can state that the arguments are equal. So x is equal to 5 squared, which means that x is equal to 25.